Hello, my name is Charlotte Beach, and this video will be showcasing the development and application of a smart Internet of Things platform, the recording of data and analysing that data. The Internet of Things is a type of network that uses physical objects such as sensors and softwares to exchange data with other technologies over the Internet. In this example, Tinkercad is used to create a simulation of a platform that monitors temperature and gas readings for a university. The components used are an Arduino, breadboard, temperature sensor, gas sensor, LEDs, buzzer and resistors.
The platform and initial design had to be created. It was decided that the temperature sensor would be placed onto the breadboard and wired to the Arduino. Once that had been wired, we placed 3 LED lights onto the breadboard, connected to individual resistors and wired back to the Arduino. The same process was followed for the gas sensor, however instead of using LEDs, a buzzer was placed onto the breadboard with a resistor and wired back to the Arduino. Once the initial design had been created, we were then able to move on to the coding. The coding essentially tells the sensors how to work and what to do.
In the simulation, to test the sensors and coding are correct, each sensor needs to be turned on and moved around to ensure that the readings, the LEDs and the buzzers are all accurate and activated at the correct times.
Once the simulation has been started, the sensors are turned on. The temperature sensor allows us to decrease and increase the temperature. Once it reaches a certain level, the LEDs will be activated, alerting the university that the maximum temperature has been reached and something needs to be done. The gas sensor works in the same way. The gas can move around freely, however, when it gets into the proximity of the sensor, the buzzer will alert the university. The results are recorded on the serial monitor. As the temperature is increased and decreased, the serial monitor will change, the same as the gas. Each recording is side by side to each other so the university has an easy read. However, these results are not saved. This is just a real-time view for the university.
The platform doesn't automatically store data. To do this, we need real-time data being inserted into a different software. The recorded data is stored into an Excel spreadsheet, however it is one big table that is hard to read. This is why a dashboard has been created. The dashboard is used to display an overview of large data. It is a creative one-stop way to show vital information for the university, whilst also making decision-making processes easier, with all relevant data being in one window.
While the
Here
sensors
you
are
can
on,
see
the data that's been transferred from the platform into an Excel sheet. This is how the data is stored. Other than the top row, which is ID, date, time, CO2, temperature and humidity, the entire sheet is a list of data, including numbers, dates and times. It's very hard to read, meaning that it would be almost impossible to find patterns without taking hours and hours. This makes it very hard for the university to properly review the results. This is where the creation of a dashboard comes in. The dashboard is initially created by making a pivot table. The pivot table selects all data from the datasheet, allowing you to pick and choose what type of data you'd like to see and how you'd like to see it. For example, for this pivot table, the date and the average of CO2 has been selected. Once the pivot table has been created, that's when you can create a chart. However, for every chart you'd like to add into the dashboard, you have to create a new pivot table. As you can see from our dashboard, we have created 5 charts. These include pie charts, radar charts, line charts and bar graphs. Each one showing the university something slightly different, giving them a different viewpoint of the data. A pie chart shows the distribution of recordings for the two sensors by day. The two sensors are CO2 and temperature. The temperature sensor quickly shows the user that an average per day is 10%, and this is from the 1st to the 10th of October. This means that there's consistency within the readings and there's no issue. However, for the average of the CO2, although the numbers are quite close, they are slightly different, showing that this isn't as consistent as the temperature. If the university would like to see different days, they are able to do so by choosing this option, allowing them access to not just one day. The radar chart shows multivariables of all three components, meaning a comparison can be made between all three sensors. For example, the average of CO2 is very high compared to the average of the temperature and humidity. The temperature and humidity are closer together, however are still different. The line chart shows a different type of comparison of all three sensors. It can examine trends. For example, it's easy to see that the CO2 is lowering consistently throughout the days, whereas the average of the humidity and temperature follows a solid line. The final chart shown is a bar graph. This compares the average sensors for all sensors, but you can choose a specific day to view. This allows the university to have a day-by-day aspect, not just over a week period. To summarise, the dashboard allows the user to have an interactive experience. Not only that, but different charts can be added and taken away. If something is no longer relevant, or the user needs to see something in more depth, they are able to. It is a system that allows the user to do exactly what they want with the data. There is no right or wrong way of displaying it.
Using the same colours throughout the design of the dashboard makes it less confusing for the user and easier to follow, whilst also giving an overall professional look. Analysing the data allows the user to see trends and patterns. This is important as it enables the user to predict results and make it clear if something needs to be changed or something has gone wrong. To improve, different types of charts could be created if sensors were placed in different rooms for a longer period of time. This would bring different results, patterns and more accuracy. Throughout the video, I have showcased the development and application of a smart IoT platform and have given an analysis of the data. Thank you for watching.